fingers in the way. Craniospinal axis simulation. What you want to do when you ballpark your patient in the normal way, she's going to be prone. Normally you're going to have the patient built up on something, say a back lock, because you kind of want to bring the patient to where their head can be relatively neutral with the rest of their body. Pixie kind of naturally does that, so we're going to be okay. What you do not want to do is have the chin tucked toward the chest. You'll come over here to the side, you can see. She's got her chin tucked toward the chest. If we have a posterior field that diverges this way, we're going to diverge into her mouth. So you want the chin up and away so she's relatively neutral. You don't want to pick the chin up like this because then you're going to have these big old neck folds. Normal folks are going to have a little more skin right here, and you've got match lines you're going to be dealing with right here, so you don't want the chin kicked up. You want the chin relatively neutral, maybe just a little bit extended, such that you don't have to worry about post-anterior exit from the posterior beam. So it's usually going to end up looking something like this. She ends up like this, that's fine. Having said that, ballpark, get them completely straight, chin relatively neutral, maybe kicked up a little bit. Make your mask. You're going to make the mask so that you can always hold the head in the right place. Arms are going to be at sides, pulled down. You're going to, like I said, you're going to have it built up on either a back locks or a piece of styrofoam, something to bring the normal patient has to be kind of built up so that you can have that relatively neutral stance all the way through here. For simulation of a craniospinal axis, you start at the inferior. We're going to assume that this individual is going to need 2 posterior fields. You're going to be working during all of this process with your physicist and your dosimetrist. They're going to determine exactly where those fields need to be, how big they want them. Normally, your inferior field is a little bit smaller than your superior field. They'll determine in and out kind of where they want to be. The reason you start with the inferior posterior is because everything you do is going to be based on 2 things. Your most inferior field edge and your most superior field edge. This entire thing, cranium and spine axis, you're treating this all as one field, but it's going to take 4 fields to get it all in. So, you have to pretend that this field edge and this field edge up here is your top and bottom borders. Everything else that takes place in between are little junctions in between them. I'm just going to leave the field size like it is because it's convenient. We're going to say the doctor said, this is what I want. You're going to have the physician and the dosimetrist determine what depth they want to treat to. Normally it's about 5 cm. I'm naturally sitting at 4 cm. I'm going to leave it there for argument's sake. So you're going to have CR, superior and inferior borders. Your width is going to be set such that it's wide enough to encompass the spine. I just did the wrong thing. It's going to look something like this. We're going to say that's it. So, you've got the depth set because the physicist and the dosimetrist decided they wanted to treat to a depth of 4 on this individual. You're going to go ahead and mark your inferior border, your superior border, and your CR. You're going to take your x-ray, get it approved. Now, what needs to happen is you're going to now move to your second spinal field. The physician ahead of this is going to determine where they want their superior junction to take place. They're just going to say, you know what, I want it right about there, and they're going to make a nice little mark for you. So now we have to fit in between here and here another field. And we're going to also assume the same depth. You can see that this might change a little bit. You're going to go in, out, Now, I'm going to shoot for halfway in between. I'm going to drop my field down until my divergence is indicating I'm at a 4 cm depth in this particular case. Then I'm going to open that field size. Not that one. This one. Now, I am now against my other field and I'm not quite to this one. So now I need to do a little bit of fidgeting. I'm going to go part way. Now that you get to this point, we know approximately what our field sizes are going to be. You've got your field size documented from your inferior border, from your inferior field. Now you've got another field size that you're going to be working with, and you've got your superior border pretty much set where you want it. The physician, the dosimetrist, and the physicist are now going to do a gap formula. You have to have this field size and this field size in order to determine what kind of gap that you need to have in between the superior border here and the inferior border here. Once that gap formula has been formulated, you're going to then have an exact measured distance between here and here. I don't know what that's going to be. I'm not going to do the gap formula. I'm not going to make you memorize what the gap formula is.
But Tony will.
Tony will do that later. You can have that kind of fun later. We're going to assume that we've got the gap set. But up here, we're still not where we need to be, so we need to do some more fidgeting. I'm just going to unlock the table for simplicity's sake. I'm going to move out a little bit. Make my field size slightly larger. There. Now we're set. With our predetermined gap,
Which is right there.
between here and here, it is approximately 0.7. And our predetermined superior field edge, we now know where the CR is supposed to be, and we're still set to our correct depth. We can now mark this guy. What we have to do to document this is we'll have a wire here and a wire here and a wire here. The wire at the superior field edge is going to drape across the neck, just like we did with the head and neck. That wire needs to lay all the way across where this field size is. Now that we can see the field size, we're going to draw that in as far as we can and give our straightening mark. Now we've got two sets of 3-point inline setups, here and here. You're going to drape that wire across the superior edge. That's going to be able to tell us how to match the inferior border of the brain. So we've got wire, wire, wire. CR. Take your film, get it approved. Once that's approved, we can now move along. So, as you can possibly see, let me draw this a little bit better. I'm sorry. Just so we can see from this side. Sometimes you can do this. It's a little trick. You can open, now that you've got your film taken. Wrong one. Open your field size a little bit, and you can see exactly how far out that goes. So we want to go ahead, carefully lay our wire right along here. Now, if you'll step back a little bit, we can see divergence. You can see the angle that that's sitting. If we follow this down to its logical progression, you can see how much further it's going to be. We're very close to the chin as it is. We're close to actually going into the person's chin. We don't want that. Whoever drew that mark is brilliant because it's not too high and it's not too low. So, we've got a wire along here. Next, we're going to simulate the brain portion. going to have a pretty generous field size change, but we're going to go in to about where I would think a ballpark for a brain would be. Up, down, you're going to go halfway between the posterior flash and the anterior flash. And we can even see that our field size is pretty darn close. You will then rotate the gantry, and it comes to wild trade place.
Okay.
Rotate the gantry over to the side. And we're going to set up our fields. We're going to open our field size such that we have. Does anybody remember what the field borders for a whole brain is? I wonder if anyone does. Flash, posterior. Flash, superior. You're going to flash anterior as well. The inferior is going to follow a slightly different line, but it's going to start at the outer canthus and kind of go along and block the face. You want to treat that entire spinal cord all the way down through here. Now, how much flash do I have? About 5 centimeters. We're way too long. So we're going to move patient out, or in, and we're going to close our field size as well. We should have the image intensifier out so you can see this, but you've got, I'm using my I should use my ruler.
Yeah.
You see we've got flash here. We've got a little bit of flash here. We need to open that field size up as well. Flash, flash. We can see the flash on the headrest here. Now, we've got a problem. We have 2 kinds of divergence to deal with right now. You not only have the divergence from the posterior spinal field, which is coming this way, you've got divergence from the inferior brain going this way. So we have to do 2 things. We're going to turn our collimator until we visually see this divergence being matched. We're turning our collimator to match this divergence. Come around to this side and you'll be able to see. This, we saw our mark. Now look at the field. You see the inferior edge? That's the same angle as this divergence from the posterior.
One more time.
This angle going this way at this angle is matching the superior border of the posterior spine field. It comes in this way. It's coming in like this. So now we're matching. Now we've also got, as a bonus, divergence from this going this direction. So what do we need to do? Just like on the head and neck, we're going to kick our table toward the gantry. Didn't mean to go left right. And do a little bit of in and out. So, just like with the head and neck, you are going to radiographically use this wire that's looped all the way across this patient's neck and overlap it on itself so it's superimposed. If you don't have the right angle set, you will see that loop will look like a U until you have the table turned enough to where it's superimposed on itself, just like with the head and neck match line. So we've done 2 match lines, 2 kicks, 2 divergence modifiers. We have divergence from this direction and divergence from this direction that we've taken care of with a collimator angle and a table kick. Now that we've got that radiographically set, we're going to run in the room, mark your patient, take your film. After you've notated gantry field size, collimator, all that stuff. You've taken this film. Now what you have to do is replicate this. You're going to rotate to the left lateral. you're going to mirror your collimator and mirror your table. So you're going to turn your collimator in the opposite direction, you're going to turn your table in the opposite direction, and you're going to mirror your gantry over to the other lateral. Then you're going to take your other film, mark your patient. Now, there's two schools of thought. There are two ways to mark this patient. Instead of marking the CR on both sides with the table kicked, you can leave that off. Once you've got your films taken, rotate your table back to 0. Give yourself 2 marks at your setup point. It's going to be a VSP. You're going to mark the back of the head. You're going to mark both laterals. That does not include your entry points for your table kicks. So you have to keep those straight. Also, a good thing to do, I keep forgetting to do separations. Before you take any films, take a separation of the head. Determine what your midplane should be. Unless the doctor and the physicist say, I want that to stay exactly in line with what we did in the first place. That's fine too. A lot of times what you're going to end up with is a 1, 2, 3, 4, 5, 6, 7 point inline setup. You're going to get the head and spine all in line. And this is offset a little bit, and you can certainly calculate it that way. That's fine. That will be determined during the simulation. You're going to have a whole team in place to do a sim like this. So, we started at the inferior, posterior spine field. Doctor determined where he wanted the entry point to be. You set that, set the depth, filmed it. Move it up to the next one. You've got another mark that you're trying to match to. You're going to set your field size such that your depth is correct along with this one. Whatever depth the doctor wants and the physicist wants, you use that. We did a little bit of walking back and forth until we had an approximate field size. You have the approximate field size, you're going to get the gap formula calculated, you're going to execute that gap, make sure you're matching up here where the doctor wants. You're going to have a wire on the superior edge of your inferior border, the inferior edge of your superior border, and the superior edge of your superior border. The wire on the superior edge of the superior border from the posterior is going to have a wire going all the way around the neck, well, not around the neck, draped on the back of the neck so that you can then see the divergence that you need to see for the cranial field. Take that film. Once you've taken that film, rotate up to the head. Ballpark the head. Once you've got the head ballparked, you're going to turn your collimator such that it matches the diverging angle that you have drawn on from the superior edge of the posterior field. Then you have to kick the table to take care of the inferior divergence from the lateral field. You're going to do that radiographically with the fluoroscope and make your wire superimpose on itself so that you can prove that your inferior border of your cranial field is matching the superior border of your posterior spine field. So, 2 angles to deal with, table and collimator. Have those set, take your film, rotate to the other side, mirror your collimator, mirror your table, mirror your gantry. Take your other film, center your table again, mark both sides and the posterior. Now you've got 1, 2, 3, 4, 5, 6, 7, 8, 9 marks on the patient. Lastly, if you want, you can give some lateral leveling marks as well. Those are handy to have because if you ever want, sometimes the patient will be potentially rotund, not like her. Giving yourself some lateral leveling marks along in here will allow you to flatten them out. As we've seen in the video on how to treat the craniospinal axis, you're getting them level is pretty important. So that's how you simulate craniospinal axis. We've used almost every technique we've gone over this semester and last in order to simulate this. So, good luck.